All right, next I would like to take a look at this problem right here. Very similar to the last one, except this time the cylinder is falling down because, right, if we read the problem, it says, while putting up holiday lights, the clumsy dad accidentally knocks a spool off the roof, and then it just has some information there about it. What is the acceleration of the spool? So it says solve for 2 different ways, and if you'll note, it gives us two different moments of inertia. So we're going to solve it once where it rotates around the middle and once where it rotates around the edge. So when it rotates around the middle, that's going to give us that one, and once where it rotates around the edge. So if we think about the forces that are acting on your cylinder, we have the force of gravity on the cylinder, and you also have the tension on the cylinder. Okay, so those are kind of our two forces acting on the cylinder. Now, when we go to sum our force, or when we go to treat it as a cylinder, so that means we're going to put our pivot in the middle here. So the tension would be the only force that exerts a torque, because mg is at a radius of 0 compared to our pivot. So when we sum our force or sum our torques, sum the torques is equal to I alpha is equal to T R, just like last time. Again, also we have our substitute in our moment of inertia there, 1/2 mr squared, and then also put in the A over R, just like last time as well, just like last time. All of the R's are going to cancel. This R in the denominator here cancels with one of the R's in the numerator. This R on this side cancels with that R on that side because they are all, it's in every R is in every term. So that leaves us with just 1/2 MA equals T. And just like last time, we can, right, we're stuck because we have an A and a T, two unknowns. So just like last time, we will sum our forces. And just like last time, it is mg minus t. Just to kind of double check that, right, if this thing falls, it's going to rotate that direction meaning counterclockwise. That means counterclockwise is positive. And if it's rotating in the positive direction, then it's going to go downwards. So downwards is positive, which means mg is positive and t is positive. So actually, these are all the same m's, so let's make them all capital. Again, just like last time, we'll solve for t. So t is equal to mg minus ma, and substitute that in for t there. So we get 1/2 ma is equal to mg minus ma. Now, there's an m in every single term, so we can cancel that out. So that is awesome. That didn't happen last time. So we have 1/2 a equals m, nope, equals g minus a. So that's going to give us 3/2 a is equal to g. So a is equal to 2/3 g. So a is equal to 6.53. So that's the first way to solve that. The second way to solve this is to treat it as though it's rotating around the outer edge. And if you do that, then tension does not apply a torque because the radius of tension is 0, but mg does. So if we try it that way, sum of the tensions, or torques, is equal to I alpha is equal to, right, the only force is mg, and it is distance r away from the pivot. So it looks like that. Then we're going to substitute in this other, right, the I for around the edge. So that's 3/2 m r squared times by a over r. Make that same substitution there. mgr. So this is very exciting. There's lots of stuff we can cancel all at one time here. For one, we can do all of the r's just like last time. This r cancels with that squared. This r cancels with this r. And we have an m in both terms as well. So looking at what that leaves us, we have the 3/2. A is equal to g. So again, A is equal to 2/3 g. So A is equal to 6.53, just like last time, or just like this one over here. So just two different ways to solve A. If we look at B, B is going to be fairly straightforward in terms of just using the kinematic equations. So how long does it take to hit the ground? I would simply write A, so you could approach this with the John equation. So, right, they fall 3 meters. This is 0. This is 0. 1/2, and then put in your acceleration there and solve for t. So that one would be pretty easy. The other, and then this one, you could just use the Ringo equation. Right, so where you're solving for v. And then once you have v, just simply put it into omega is equal to v divided by r, and that would turn it into radians per second for you. So I'm not actually going to do those out just for the sake of time, but that's how you would approach those problems. So that should help you stay caught up. So thank you for watching.